All right, this is a basic geometry self-exam number 1 with me, Colonel Alan M. Morris. We're going to take a look at number 1. Here's the way this works. If you'll click on the stop sign, study the drawing, then you can come back and take a look at it, and I'll walk you through the answer. So click on the stop sign, try to solve the problem. Then come back, click on the go sign, and see it worked out. All right, let's see how you did. And that is, if you studied the drawing here, you would recognize that this part of the drawing is just a mirror reflection of this part of the drawing over here. This line right here means that this little line right here means that this line is the same length as this line over here because it has this. So this is 50 and this is 50, and we don't know what this is. But we do know that this hypotenuse right here and that this hypotenuse right here are equal to each other because they're mirror image and they're right triangles. And so we know that 3x plus 12 is equal to 5x minus 18. This is a messy way of writing some number. And this is a messy way of writing the exact same number. And when you compare the two to each other algebraically, you're able to figure out what the value of x is, and then you're able to figure out what the actual number is. So the question says, what is the value of x? Well, here we have an x and there we have an x. So let's set this up in an equation. We have 3x plus 12 equals 5x minus 18. If I add 18 to each side, and you don't have to do that first, but that's what I chose to do. I add 18 to each side, and this negative 18 plus positive 18 just becomes a 0, and so I'm left with just 5x on that side. 12 plus 18 is 30, so now I have 3x plus 30 equals 5x. Subtract 3x from each side to keep the balance, and I wind up with 30 equals 2x. Divide both 30 and 2x by 2, and I wind up with x equals 15. Go back and reread the original question to make sure that you've answered the question that is being asked. What is the value of x? Yes, x equals 15. So if that's what you got, you're doing it right. Number 2, the exact same drawing. It says, what's the length of the hypotenuse or line OF? So you already know that x is 15. It's the same drawing. Click on the stop sign. Try to solve. All right, let's see how you did. And that is, we wanted to know the length of this hypotenuse here. We already knew that x was 15 from the previous slide, and so we just plug that in. 3 times 15 plus 12 equals 57. If you got 57 for the length of this hypotenuse and the length of this hypotenuse here, you're doing it right. Number 3, click on the stop sign. All right, let's see how you did. What's the length of line PF? That would be this line right here. And it's one of the legs of the triangle, this being the hypotenuse, this being the other leg. And what did we already know? Well, we already knew that this was 50, and we already knew that the hypotenuse was 57. So we're going to be looking for, let's see, if we take 50 and square it, and then put that under a square root sign, we get 3,249. Then we subtract 2,500, that's 50 squared. We subtract the square root of 2,500, or excuse me, just 2,500 from 3,249, and we get 749. Throw that under a square root sign, then solve for that, and we come up with the length of PF, correct to 2 decimal places, is 27.36. And that seems to make sense. Evaluate your answer. The longest line in a right triangle is the hypotenuse. This is 50. This is 27. Does it make sense that this would be 57? Yes, it does. All right, number 4, click on the stop sign. All right, let's see how you did. What is the length of the line OT? This is point O, and this is point T. Let's see, 50. O to P is 50, and they're mirror images of each other, so P to T is another 50. So 50 plus 50 is 100. All right, click on the stop sign. Now, let's see how you did. And that is, we have this drawing here. Looks like it's an isosceles triangle. This is 126 and this is 126. Might be an equilateral triangle if this was also 126, but we don't know that yet. So let's see how you did. Let's see, it says, what is the value of x? Here is x, this is 5x, this line, and this line here is 3x plus 24, so that's the x. So we need to find the value of x. It says line BD, that would be this line right here, line BD bisects angle B, that would be this angle right here. It says bisects angle B, find the measure of AC. So what's the total length of this line right here? Well, if this is truly the angle bisector, then that means 5x is equal to 3x plus 24. Work that out algebraically. 5x equals 3x plus 24. I subtract 3x from each side. I wind up with 2x equals 24. Divide both sides by 2, and I get x equals 12. Go back and reread the original question to make sure that you are answering the question that is being asked. What is the value of x? X equals 12. You've done it. All right. Same drawing. So click on the stop sign, read the question, and try to solve it. All right. Let's see how you did. It says, what is the measure of line AC? Well, we already knew that x was 12, so 5 times 12, that's just 60. And 3x plus 24, that's another way of writing 60. But it wants to know what's the length of this line plus that line. 60 plus 60 is 120 units. We don't know what they are, but we do know that it's 120 units. All right, same drawing. Click on the stop sign. Try to work it out. All right, let's see how you did. It says line BA. This would be this line right here. Line BA and BC are both 26 units long. Line BD is an angle bisector of angle ABC. So this is the angle bisector. We already knew that. What is the length of line BD? That would be this line right here. How long is that? Well, what we have, this is the bisector, and this is an isosceles triangle. So what we know is this is our hypotenuse, this is a right angle right here, and this is 60. So let's take a look at what that would look like. Here we have a right triangle. We're trying to find the length of this line right here next to this parallel to this red line that I drew. So we have a length of 60 and a hypotenuse of 126. If we square 126 and throw that under a square root sign, we get 15,876. And if we square 60, we get 3,600. Throw that under a square root sign. In other words, this number right here, the square root of 3,600, is just another way of writing 60. Now, if we take 15,876 and subtract 3,600, we get 12,276. Find the square root of that, and we come up with 110.79. That's correct to 2 decimal places. You might want to just round that to 111. And so the correct answer is, what is the length of line BD? The answer is 110.79 units long. All right. Click on the stop sign. It's the exact same drawing. Click on the stop sign and see if you can answer. All right, let's see how you did. Well, the perimeter, that's just how you find the total length around. It's kind of like a fence. It just goes along the edge here. And so we already knew this was 26, and we knew this side was 26, and we had calculated that AC was 120. Add those 3 numbers together, and you get 372. If you got 372, you're doing it right. Okay. Click on the stop sign and see if you can solve the problem here. By the way, we calculated that this length BD right here was approximately 111. I think you can use that to solve this one now. Click on the stop sign. All right, let's see how you did. The formula for finding the area of a triangle is base times height divided by 2. What is the area of triangle ABD? That would be ABD, this triangle right here. What is it? Well, we know that this is 60 and we know that this is 111. So when you work that out, 60 times 111 divided by 2, you have to divide it by 2, will give you the area. And if we use 111 as this length right here, you wind up with the answer being 3,330 units squared. Okay, click on the stop sign and see if you can figure this one out. All right, let's see how you did. Well, we're dealing with an equilateral triangle, and an equilateral triangle tells you that all of the sides are the same length. And if all of the sides are the same length, all of the angles are the same length too, and they all happen to be 60, by the way. So what is the perimeter of triangle ABC? 38 plus 38 plus 38. And so that's 114. Okay, now let's take a look here. What is the angle BAC? Click on the stop sign. All right, let's see how you did. Angle BAC. A, by the way, is the middle letter here. That means that that is the vertex of the angle. So we have BAC, and it's an equilateral triangle, so all of the angles are 60 degrees, and so angle BAC is 60 degrees. All right, click on the stop sign and try to solve this problem. All right, let's see how you did. 60 degrees plus 60 degrees plus 60 degrees is 180 degrees, but you already knew that because the internal angles, when you add up the internal angles for all triangles, they are 180 degrees in all known universes and beyond. All right, click on the stop sign, see if you can figure this one out. All right, we're going to see how you did. We have line DE, that's this line right here. So we have line DE, and line DE is extending from the midpoint of BA and the midpoint of BC. In other words, it's in the middle. Well, it's an equilateral triangle, so we know this total length right here is 38, and it's at the midpoint, so that means this length right here is 19, and this length right here is 19. This is 60 degrees, that's 60 degrees. These are proportional triangles. And this one right here, the BDE, happens to be 1/2 of the larger triangle, dilated by a factor of 1/2. Well, if all sides of an equilateral triangle are the same length, and we know this is 19, then by default, this has to be 19 right here. So that's one of the ways. There's several ways to figure this one out. But I will press on. All right, click on the stop sign. What is the exact altitude of this triangle? All right, let's see how you did. And that would be the exact altitude. That's the height, the total height of the triangle. It's right here. It's not the length of one of these sides. That only works out when you're dealing with a right triangle, that the altitude or the height and the altitude are the same as the length of one of the legs. We can't do that here. So what we're talking about is this right here. That length right here is the altitude. Well, we have a right triangle. We know that this is 38 and we know this is 19, so we're just calculating the length of this line. If I write 38 under a square root sign, I can write that as 1,444. Is the length, the square root of 1,444 is the length of the hypotenuse, and this length of this leg right here is 19. But if I write 19 under a square root sign, it's 361. If I now subtract the number 361 from the number 1,444, I get 1,083. Throw that under a square root sign, and that gives me the length of this side right here. And the question says, what is the exact altitude? This is the exact altitude, because if we pull this out, this is an irrational number. If we pull this out from under the square root sign, we can only know it correct to a few decimal places, or several decimal places, but we'll never know it perfectly. This is the perfect answer, or the exact altitude of triangle ABC. All right, try to see if you can figure this one out. Click on the stop sign. Angle ABC is bisected by a line from point B to the midpoint of line AC. So there's a bisector that goes on right here. What is the length of the angle bisector? Well, you already figured that out when you figured out the altitude. It's the square root of 1,083, which if you pull it out from under the square root sign, correct to one decimal place, is 32.9. So either this is the perfect answer, this is correct to one decimal place. All right, what's the perimeter of triangle ABC? Well, we actually already calculated that. So click on the stop sign, see if you can figure it out. All right, 3 times 38, because all sides of an equilateral triangle are the same, and this is 38. 3 times 38 is 114 units long. What is the formula for finding the area of a triangle? Base times height divided by 2, or 1/2 times the base times the height, or base times the height times 1/2. Doesn't matter when you're multiplying. I could multiply the height times the base times 1/2, so that doesn't matter. But these are the formulas for finding the area of a triangle. If you're not dealing with a right triangle, you have to know what its altitude is. All right. What is the relationships between the lengths of lines A, B, and C? Click on the stop sign. All right, let's see how you did. And that is, we take a look at the relationships of A, B, and C. Well, these three little lines right here and these three little lines right here tell us that this line right here is equal in length to this line right here. They are also called congruent. And this little mark right here tells us that we are dealing with a 90-degree angle. So if this is the same for this, if these two are related to each other and these two are related to each other, then this is a right triangle that is a mirror image of this right triangle right here. In other words, this length is the same as that length, and this length right here, this leg length right here, is exactly the same for a triangle with hypotenuse A and triangle with hypotenuse C. That tells us that A is equal to C and C is equal to A. We don't know what they are, but we know that they're equal to each other. And if you take a look at that, we have a right triangle here, and we know that this length right here is equal to that length right here. Right triangle is a reflection of this right triangle right here. So if these lengths are the same and this leg is 3, we know that, it at least gives us that much, then we know that this hypotenuse A is equal in length to this hypotenuse B, and so what that means is A, B, and C are all the same length. All right, if lines A and C are both 5 units long and the angle bisector between lines A and C is 3 units long, this is 3 units right here now, what is the length of line OM? Click on the stop sign and solve. Okay, let's see how you did. Well, we know that if we have here, it says that this length right here is 5, and this length is 5, and this length is 3. Perhaps you recognize that this is the 3, 4, 5 triangle, and this is the 3, 4, 5 triangle. And that means this line right here is 4, and this line right here is 4, and 4 plus 4 is 8. So the length of line OM is 8 units long. All right, line T is the traversal line, and so we have 2 lines that are crossing here. And what is the relationship? How is A related to A prime? Click on the stop sign, think about it. All right, let's see how you did. Well, first of all, they are exterior angles, and they are on alternate sides of the transversal line, so they are alternate exterior angles. And if I say alternate exterior or exterior alternate, don't get wrapped up in that. It's like eating a peanut butter and jelly sandwich or a jelly and peanut butter sandwich. It's the same thing. It's just the words have been mixed a little bit. All right, let's take a look at how B is related to B prime. Click on the stop sign. All right, let's take a look at this. Well, let's see. We have one that is outside and one that is inside. When you have an outside angle and an inside angle, when dealing with a traversal line, you are dealing with corresponding angles, and they are on opposite sides of the line, and so we say that that is alternate. So we have corresponding alternate angles, or alternate corresponding angles. All right. Let's take a look at C and C prime. Click on the stop sign and see if you can figure it out. All right, they're both interior. This is an interior angle and this is an interior angle, and they're on the same side of the line, so they're interior, same side, or they're same side, interior. All right, we have 2 parallel lines. Lines N and M are parallel to each other, and they are crossing the Cartesian coordinate plane And so this is the x-axis and this is the y-axis. Let's see, angle 2, that would be this one right here, is 50 degrees. What is the measure of the other angles? 1, 3, 4, 5, and 6. Click on the stop sign and then come back and let's see how you did. All right, we were told that angle 2 was equal to 50, and so we have it equal to 50. So if angle 2 is equal to 50, then the angle opposite is also equal to 50. Because when you have two straight lines and there is an angle on one side, the angle on the other side is also the same measure. And let's see, we already know that x and y are 90 degrees to each other, so this is 50 and this is 90, and we know that the interior angles of all triangles sum or total to 180 degrees, which means that that becomes 40. Because 90 plus 50 plus 40 is 180. And now we have two straight lines that are crossing, and if two straight lines are crossing, then that means the other angle, opposite, or angle 3 in this case, would also be 40. And then let's see, if this is 90 degrees, then angle 4 is also 90 degrees. And then if, let's see, if this angle right here is 50 degrees and this line N is parallel to line M, and this is a straight line, then so this is 50 degrees, 6 would be 50 degrees. And so we wind up with 6 being 50 degrees, and now the only one we don't know is angle 5, and we know that 6 and 5 are supplementary angles and that they will total to 180 degrees. So we take 180 minus 50, and that gives us 130, and so 5 is 130. All right, your comments, questions, and suggestions are welcome, encouraged, and always appreciated. You may write to me at alanmorris@yahoo.com.